Welcome to Building the Business Behind Open Source AI. Wrapping up our forum on open source AI monetization, we have Romi Datta. Romi previously led product for AWS SageMaker and Bedrock, and is now the founding head of product for DataRobot's agent workforce platform. He'll be discussing how to govern and monetize agentic AI across every environment, from public cloud to hybrid and air-gapped data centers.
Thank you very much. Yeah, it's always a great sort of homecoming coming back to these offices. Haven't lost a lot of the familiarity out here. So let's talk about what is DataRobot. We say that DataRobot is the agentic platform for the modern workforce. That is a loaded term. What does that even mean? As you talk about agents today, they're effectively the modern worker. And as you talk about agents being the modern worker, what you're talking about right now, and that's how we're talking about it with all of our enterprise customers, no one's talking about a single agent or your classic chatbot. They're talking about entire workforces of agents doing tasks, sort of a role collapse as well as a time collapse to achieve certain outcomes. And that's what DataRobot has been at the forefront of. We have been co-engineering this with our partners NVIDIA, and we have a bunch of other select partners, including Dell, AWS, Google, and SAP, among others. We have been around for 12 years or 14 years now. And this company was the pioneer of AutoML. And then we pivoted towards keeping the classic predictive world together while using that as a tool in the agentic world. Key flagship customers who are using us today across span industries and geographies, whether it be NVIDIA, who runs their inference on us, Dell using us in their on-prem environments, Chevron using us for some cool use cases I'm going to show, Geico, Aon, as well as globally Saudi Aramco, Dubai Telecom, or as they've rebranded themselves as DO, and then customers across the world in Europe, Japan, and rest of Asia Pacific. What have we seen over this last, I would say, 18 to 24 months? How the concept of agentic AI has evolved. And a lot of that we are going to talk about is that how open source has enabled some of this, and also how governance, monitoring, and platform agnosticism has led to these a further progress in this world. So there were the whole idea of co-pilots, chatbots, single app conversational agents. Great. We started with that. Great for user productivity. Very soon we have seen a migration towards sort of autonomous agents in your current systems of record or current business record systems like Salesforce or in Workday. Okay, you would automate part of a business process. But often people come and tell me, like, what exactly is new about that? And it's like, probably not much that that you can, because you're making a deterministic process, okay, automated and putting some LLMs on it and making it interactive. Is that truly agentic? I mean, if you talk to a science person like Andrew Na, he's going to bristle at that term. But when you get to like agents, what are agents? It is the specialized software which understands your corporate context, institutional information, aware of your businesses, provides you value in a particular outcome, and works across different systems of record, across your different data stores, across your Salesforce, Workday, ServiceNow, and your supply chain systems, and gives you specific outcomes. What is the ripe target for this? Basically, you're talking about anything that required like 20 different people approving processes and things like that. That is where you need agents. Why are they called agents in the first place? Because they have agency. They can make a decision on their own. If you needed a deterministic workflow, that's not really an agent. And that evolution, as we see, we have seen that manifest itself in two kinds of agents. One, where you are actually reimagining existing processes, finding a better way to do insurance claims processing. Okay, finding a better way to do your supply chain planning. Not just automating it, just finding a completely better way to do that. Or alternatively, really reimagining what things could be done. And I'm going to show you some small use cases of each one of these really attractive ones. So let's start with the first one. We basically have a whole curated collection of these agents we have built for our customers. Okay. And I'm going to show you one of them out here.
Welcome to the Agent Marketplace by DataRobot, a curated collection of high-impact agentic AI applications designed to solve real business problems and drive measurable results. This isn't experimentation. These are production-ready, outcome-focused AI agents built to deliver ROI. Every application in the marketplace targets a specific business challenge, from revenue growth to operational efficiency to risk reduction, powered by intelligent, autonomous agents that reason, decide, and act. You don't just get a model, you get an agent workforce built for impact. Let's check out a few real-world examples. Take our claims processing support agent. Global insurers face a massive operational hurdle: manual adjudication. In one representative case, this created a 150,000 claim backlog and 40,000 monthly exceptions. Increasing first-pass approvals by a mere 3% can reduce the manual processing burden by up to 50% and accelerate payment cycles, thus improving customer satisfaction. Let's see it in action.
The agent automatically processed 10 claims and performed a preliminary coverage analysis. The list provides an at-a-glance view of the agent's recommendations. Looking at one claim, the agent extracted key data from the claim PDF, assessed the service details against that member's existing coverage, and recommended a disposition based on prescriptive business rules. The agent surfaces its recommendation rationale to the claims adjudicator for ultimate decision-making. The adjudicator can review the exact data the agent used in making this decision. They can also interact with the agent directly, or use it to consult the applicable company policies. This agent reduces the manual claim review effort by up to 50%. But more importantly, it cuts down adjudication time in half, which improves customer experience.
So that was like how you reinvent like existing processes. Insurance claims processing, it's a very, very cumbersome task. It has a lot of exceptions, a lot of rules, and insurance actuaries are actually one of the highest paid employees in this country. And so there are a lot of things we have been working very closely with some of our partners in the oil and gas industry. And a lot of those factors, I mean, when we talk to them, they're like, yeah, Landman's not completely imagined. But in the first season, almost the beginning of all of this is this scene where a crew goes out to inspect a leak. And that starts the entire whole cascade, right? I mean, for ruining suspense for some of them, but it basically, there is a spark and it causes an explosion and the entire oil field is on fire, okay? And casualties. Well, the first question technologists come and think about it, like, why did they send a crew out? Why can't you send an automated robot? Like, what's wrong with it? Anyone has an answer why they can't send it? Why can't you why can't you check in your laptops or lithium-ion batteries inside your checked-in luggage? Spark risk, yes, fire risk. So you send a drone, you can set the entire oil field on fire. So that was an interesting problem, our customers Chevron came up to us with. And we said, okay, so now let's try to reimagine how things are done. What if you did not have to send a crew? Well, we have no problem investing in drones, but there's a problem with that. So we started talking and then, and this was actually a direct initiative driven by Jensen. He has been talking about driving industry-specific models like PhysicsNeMo, BioNeMo to drive transformation in conjunction with large language models. And so we saw that kind of an amazing marriage of NVIDIA, DataRobot, and our customer Chevron coming together and transforming facilities, oil facilities and gas facilities, and making them much, much safer and changing the processes. So I'm going to play a very interesting video out here of what we did.
At Chevron, safety is a core value. Working with DataRobot, Chevron can deploy AI decision-making at the edge to reduce risk to workers and enable safer, more efficient operations. Worldwide, Chevron uses aerial and terrestrial robots to inspect and monitor equipment for abnormal conditions. However, each robotic mission still requires operator verification of safe conditions, which slows response time, and requires personnel to enter potentially hazardous conditions. With Data Robot, Chevron can enable autonomous operations for both drones and operators. Behind the scenes, this is powered by a new class of AI infrastructure.
Here's a look at a Chevron facility with two main production units. Across the miles of pipe and operations, field workers are essential to ensuring safe operations through the execution of daily rounds and routine operator duties. Now, let's look at how an agent, built on DataRobot's Agent Workforce platform, co-engineered with NVIDIA, helps Chevron safely inspect and assess the site with aerial and terrestrial robots instead.
The concept leverages existing hardwired gas sensors, supplemental vision systems, and AI models to confirm a stable environment and trigger mission execution without manual hot work permitting. In simple terms, we're shifting from manually approving every mission to continuously validating that conditions are safe in real time.
Here, we have multiple agents built and deployed on DataRobot that will help predict the movement of a plume during an anomaly. One agent passes on the relevant info, like the wind speed and origin coordinates of the plume. Confirming atmospheric conditions is only the first step. We need to understand where the abnormal condition is. With greater situational awareness and insight into the probable source, the operator can easily chat with the agent to evaluate conditions. Once the agent has determined the predicted movement path of the plume, it uses this information to calculate the optimal route for the drone flight to inspect equipment. The agent passes along safety constraints associated with the gas plume movement and other parameters defined by the operator. As the drone collects imagery or video, it appears for the operator. An agent keeps drones operating in gas-free areas, protecting human staff from hazards.
This approach addresses the industry challenge of non-certified robotics hardware by shifting the focus to environmental safety assurance, thereby enabling us to reduce human intervention and accelerate robotics deployment.
Let's look at the agent workflow and how all this works. The first agent built in DataRobot uses NVIDIA Nemotron to get gas sensor information and invokes an NVIDIA Physics Nemo simulator to create plume mapping using local sensor data, including wind and other weather patterns. The agent also asks for the time horizon to predict the plume movement. Given the leak location and current wind pattern over the facility, DataRobot's physics-informed neural network returns a forecast on how the gas plume will evolve over the next 5, 10, and 30 minutes. Then the DataRobot agent calls NVIDIA cuOpt to provide optimized drone routes to monitor the leak. DataRobot's guardrails and monitoring, powered by NVIDIA Nemo, ensure the agent's predicted paths for the drone adheres to Chevron's safety standards. Next, the Chevron operator inspects the suggested path before assigning the drone a safe path to inspect. They can assess the route, facility maps, and images to determine whether to add additional constraints to the route. The operator can provide this guidance interactively to the DataRobot agent via natural language chat. Once the agent takes the additional constraints from the operator, it invokes cuOpt again to find a new route. Because this is a mission-critical system, every inference and autonomous move is governed and monitored centrally with DataRobot.
This is the agentic transformation in action at Chevron, where intelligent systems perform mission-critical tasks and invent new ways of working.
Together, Chevron, DataRobot, and NVIDIA are building a smarter, safer way to power our world.
So what you see out there actually was all built with open source components. An open source large language model, Nemotron, orchestrating as the brain of that agent, open source physics Nemos and cuOpt calculating the plume movement, figuring out where that gas plume or leaked gas plume can move, because if it's flammable gas, you do not want it to come in contact with the drone. And then open source cuOpt figuring out how to send the drone out there through a safe route. So then the question happens, all of this open source stuff is there. Why do you need DataRobot? Just like LLMs exist, often people ask, why do we need platforms? And This is not a new question. People often have asked me this for the last 6-7 years when SageMaker first came out, and what was the reason? Why Data Robot? And the analogy I give is, why do you need purpose-built platforms? For industrialization, for making this operate at a scale where it is enterprise-wide scale, which is enterprise-wide. Take two examples through history of humanity. Carl Benz invented the engine, automotive engine, 1885 or 1886, I believe. But the cars didn't become mainstream. People were driving hobby cars in Le Mans even in the early 1900s. But it was only, probably right after World War I or around that time that we started seeing a lot of cars becoming mainstream. And what made cars mainstream? Two factors. One was standardization. You could have the Ford Model T in any color as long as it's black. And second was purpose-built set of tools, which included the assembly line, as well as other things like moving your suppliers very close to you and things like that, which Henry Ford did. Fast forward about 80 years, software was being written in IBM mainframes in the 60s. Why did software become so mainstream in the early 2000s and everything got transformed with software? Again, standardization. You had standardized IDEs, you had API interfaces so tools could talk to each other, and purpose-built set of tools like GitHub repos and other things which could make software go ahead. And that is at the essence of why you need a purpose-built platform. It's not to try your pilots for AI, but you can do that with open source or proprietary models today. Or I can build a bunch of things with Claude Code right now sitting in my own desktop without writing any code. In fact, actually, it's all vibe coded now. But can I put that into production? No. And that is where you need a platform. And that's where this divide happens, that we still see 95% of the enterprise agentic pilots are failing to deliver measurable ROI. And this is, interesting thing which Bank of America said is that, you sold us a bunch of GPUs. You sold us a Formula One car. Now you have to help us as local car mechanics drive this race car. Beyond just GPUs and beyond just components and libraries and tools, you need a platform to drive that agentic transformation. The reality of it is that you have a bunch of jobs you have to do before you take your agent to production. Data preparation, building your agent, identifying the right architecture, connecting it to the different data sources and enterprise systems you have, ensuring that it respects your role-based access control and your enterprise authentication and authorization mechanisms, finding the right infrastructure to deploy, setting up observability, setting up real-time intervention, governance against security, operational, and other risks. All of that takes time. You can put together all of these things by using a combination of open source and proprietary software. It'll take you probably, what we're hearing is on an average, it takes you like 12 to 16 months to get an agent to production. And guess what? It's not about just building that platform and that agent, you have to also maintain it. And that is when, for especially folks in AWS, we used to have a story that, who's going to answer that page at 3 a.m. in the morning. And that is what Data Robot provides, that we provide you a platform to build, operate, and govern your agents in any environment, whether it be hyperscalers, on-premises, air-gapped, okay, using a choice of tools, whether it be open source or proprietary, and kind of with connectivity to different data sources, managed RAG system, so on and so forth. And what does that really entail? Okay, it entails capability to runtime. What does the runtime give you? A scalable, cost-effective inference, whether it be on the cloud or on premises, combined with governance, monitoring, and real-time intervention and moderation built in out of the box. It's like making your kid do homework. You have to do it homework every evening from 6:30 to 8:30. So governance is out of the box. You choose to get rid of it, yes, you'll have to have some approval workflows to get rid of that governance. And then secure context management with fully managed RAG systems, agent identity concepts, as well as agent memory all out of the box inside, integrated with your system, and also things which integrate with your existing enterprise data warehouses and systems of record. You could build agents. You can build agents anywhere. Cursor, Cloud Code, anything. What does DataRobot do? You just have to include the DataRobot library. Today we integrate with Cursor. We're working with Claude on that, or any other local developer environment. We provide all the enterprise hooks to abstract away infrastructure, and also all the hooks for guardrails, for evaluation. We were one of the pioneers of coming up with the concept of tracing the execution of an agent and providing monitoring at the inputs and outputs of every tool inside an agent. And then obviously a whole collection of tools for which are industry specific as well as models. A lot of this, we do it with NVIDIA's, sort of like an operating system on top of the NVIDIA software. So we work with NVIDIA, we integrate their Nemo agent toolkit, which provides a YAML-based builder environment and also a runtime for the agents. We provide a lot of our evaluation is powered by the Nemo evaluator. For deployment, we provide a whole collection of NIMs, including Nemotron. And then again, you can monitor and govern with Nemo guardrails and Nemo evaluator. And then on top of it, you can use NVIDIA's open source blueprints. There is a knowledge workflow where you can have a managed rack system and agent memories in the center. Okay, our workbench you can build, but we let you build on Cursor and say deploy on DataRobot. That is the kind of flexibility we do. We let you deploy and monitor and scale your agents, and then governance we provide against governance against compliance risks, security risks, and operational risks through things like real-time intervention and approval workflows. And as we end, there is a future coming to us, and we need to be ensuring that this future is about leaving a world better for the next generation, for others. As pioneers in AI, all of us out here in this room and around us, we have a duty. And one of the things I've heard of and seen is that how hard is drug discovery in this world? And that's one of the next challenges DataRobot is taking on with some of our select customers. It's a teaser of things to come. Okay, no way we've cracked the code for cancer discovery, and we're not even going to boost it.
That reaches a patient, thousands fail. The journey takes a decade. The cost? Billions. And the cost is paid in something no balance sheet can show. Time the patient does not have. Discovery is the first chapter of every medicine and makes the difference between a successful life-saving product or billions of dollars in failed clinical trials. Identifying a viable drug candidate is a low probability process. Sequential, manual, unforgiving. It requires identifying thousands of protein candidates and thousands of drug candidates and understanding how these interact with each other. That means simulating millions of interactions, which takes years. Computational biology has existed for decades. Scientists have been simulating these interactions in silico for years, filtering out low-quality compounds before they ever reach the wet lab. Foundation models made the technique more powerful. They also made it harder to use. Most research teams do not have the compute, the orchestration, or the infrastructure to run them. Until now, DataRobot and...
Okay, I'm going to stop here because this is the part which is going to come. We're talking about how we can accelerate drug discovery by shortlisting the number of candidates you send into clinical trials by leveraging BioNeMo. And of course, that's just an upfront candidate list. And as I said, like large pharma probably has that ability. But should drug discovery always be the purview of the large pharma? We want to actually work with, or rather democratize this drug discovery process by shorting down the candidate list. Okay, so that's my presentation. Thank you very much.
Thanks again, Romy. That was a wonderful talk.